All right, stats, here we go. So today's isn't very long. It's going to require you to do some things on your own that we'll bring to class, and then I'll have you answer on Edpuzzle. But we're going over 2.2 normal distributions. It's going over what's called the 68, 95, 99.7 rule for normal distributions. I'm going to tell you this is probably the most important concept you will learn. And chapter 2 is huge when it comes to success in stats. So chapter 2, if you haven't been taking it seriously, you probably need to get on the ball and really get after it. So let's look at this. So what I did here is that first thing in your notes, it gives us the mean and the standard deviation. I want to draw your attention to some terminology here. The big N is for population, the little n is for sample size, so this is population. And then mu is our population mean, and sigma is our population standard deviation. So if you see something like this, this is telling you that our population mean is 149 and our standard deviation is 9. So basically what we do with that is we label our number line, and this is centimeters tall, I think, or something like that. Yeah, so this is centimeters tall. And we do our number line, and then we put our mean in the middle, and then we're just going to add 9 3 times, and then we're going to subtract 9 3 times. Okay? So basically what this is telling us is that in a normal distribution, which hopefully I can draw it decently, in a normal distribution, there we go. That's close enough. In a normal distribution, we have very specific dividing lines. I'll put this one in pink here. This is 1 standard deviation. This is 1 standard deviation. All right. This is 2 standard deviations. This is 2 standard deviations. And then our last one is 3 standard deviations and 3 standard deviations. And then of course, I'll put this in brown in the middle. We have our mean, which is at 0 standard deviations. All right, so 1 standard deviation away, 2 standard deviations away, and 3 standard deviations away. Okay, now let's go ahead and tackle pink here. So remember, this is a rule, so it's something that can be repeated over and over and over again. This here, between 1 standard deviation away on either side, has 68% of the data points. Always. We can roughly estimate that it's approximately 68%. So if you see a standard deviation, if you have the standard deviation and you can go 1 either side, you can say 68% of the population is going to fall between 140 and 158 without doing any calculations. Then if we go to the green, I'll put it in here because I'm going to run out of room on mine. Mosquitoes are crazy in my room. If we go out 2 standard deviations, that's going to be 95% of the population is between 2 standard deviations. So if we look at the 12-year-old males, 95% of all 12-year-old males fall between 131 and 167 centimeters when it comes to their height. Okay? Just by knowing this, I know that if I pick 100 12-year-old males, that approximately 95 of them will be between that tall. And then the very last one, which is in orange, goes from here all the way across to here. And that tells us there's 99.7%. So almost 100% of all males, 12-year-old males, are between 122 centimeters and 176 centimeters. And you know that just by knowing the mean and the standard deviation. So that is the 68, 95, 99.7 rule. And then you can do the math and you can fill this in. This is 34% and this is 34%. So I would go ahead and fill those in if you can. And you're like, well, how do I do that? Just do 95 minus 68 divided by 2 and split it in half. And then you can split this in half. I can tell you that this is 0.15 and this is 0.15. So you can fill these chunks in, and we'll come back to that here in a little bit. So that's the basic rule right there. The big one is 68, 95, and 99.7. And I'm going to draw your attention to this one. 95% is a big number for us. So we'll get to those things. So let's tackle. So when you're looking at your notes, there are a couple of dot plots. I want you to follow the directions. I'll have you put your answer in Edpuzzle, and then we're going to do something in class tomorrow to kind of finalize those ideas. But this is kind of an activity that talks about this. So we'll tackle that here in a little bit. So do you need to know Chebyshev's rule? No, you don't need to, and I don't even know if I said that right. You don't need to worry about that. About what percentage of 12-year-old boys would be over 158 centimeters? So let's look at this. I'm going to erase some things here. I'm going to erase this stuff so we can see. It's always good to shade what you're looking for. So I'm going to use, oh, here's red. There it is right there. I'm going to use red, guys. So it says in that first example about what percentage of 12-year-old boys will be over 58 centimeters tall. So we're going to be, so what percent are greater than 158 centimeters? So if we set this up, come on in. Hi, Kayla.
Good morning.
Our custodians are working super hard, painting the school, taking care of stuff. So when you see them, when we get back, give them a thumbs up. No, not today. I don't need it. Thanks.
Thanks.
So if you take 158 centimeters and I want everything to the right, I'm just going to shade in everything to the right. So then I go, okay, well, I know that this is 50. Let me backtrack here. This whole thing is 100%. Remember, this whole thing is 100%. So out to here and out to here is 100%. So we're always starting with 100%. And so I want to know everything to the right of this. So you can add up these chunks, or I can look at it going, okay, well, half of it's got to be 50, so I got to take off half of it. And then the other half is 50, but I'm missing 34% of it. So I'm missing 34% of it. And so what is the percentage? So if we do that math, it's going to be what? That's 50 minus 30, that's 20, 16%. 16% of the 12-year-old boys were taller than 158 centimeters. What's our next one here? What percentage of boys will be between 131 and 149? So let's go ahead and go over here. 131 and 149. So no longer are we taking what we want on the left and the right. We're taking what we want in between. Okay? So what do we got here? Well, I'm gonna assume that this is half of this is 47.5, and if it's 47.5 to here, then this is 13.5%. Does that make sense? So then this is going to be 2.35, and this is going to be 13.5%, and this is 2.35. Let's fill this in. Let's double check and see if we're right. Get my calculator. It's been about as long as you guys have since we did some things. So let's just add up one side. 34 plus 13.5 plus 2.35. Oops. 0.35 plus 0.15. 50%. Okay, good. So my math in my head was right. So what I did is I just added up these because I got 50% of this left side. So in between each of these boundaries here is the percentage that's contained. So I got 34 and 34 make 68. 34 and 13.5 on both sides make 95. 34, 13.5 and 2.35. Add those up, double it, you get 99.7 between the two. So if we're looking at 131, there are 13.5% of the boys are between 131 and 140 centimeters tall. Okay, so that's kind of how we deal with our standard deviations and the basic rule for it. So that's 68, 95, 100, 99.7 rule. So let's tackle that. Last two examples. They give us a little bit different look. Suppose the distribution is normal. It automatically tells us it's normal. It has to. You either have to prove it's normal or they have to tell you. The middle 95% of the scores, so remember, we go over two standard deviations. So the middle 95% contains two standard deviations. Okay, remember that. So they ask about the middle 95% are between 72 and 84. So they want to know what are the mean and the standard deviation. Well, let's find the middle of this. So if we subtract that, we get 12 divided by 2 gives us 6. So I would say this is 78. So my mean is, my x bar is equal to 78 because it's in the middle. And then how do I get from here? This is going to be 75 and this is going to be 81 because I have two standard deviations. This is 6. Divide that by 2 gives me 3. So that means my standard deviation is going to be 3. Okay? A couple different ways to handle that, but again, we're using the 95 of the 99.7 rule, 68, 99.7 rule. All right. So that's how we're going to use those pieces. So now let's just take that last question and you can answer it in Edpuzzle. Can you calculate the percentage of scores that are above 80? So we've got this information now, and we know that right there is the first standard deviation, but they want to know the x is what? Greater than? Yeah. Greater than 80. So now all of a sudden we're not on a standard deviation. So the question to you is, can you calculate that? Explain. And that leads us into our next one. Have a good day, guys.